Hello everyone, good morning to all. So all of you are welcome here in this session. This is Sumit here. I'm the physics faculty at Infinity Learn. So in this session we are going to discuss problems. Okay, I'm going to give you the solutions of all the problems from JEE Main paper which was held on 22nd of January, second shift. So we are going to discuss only the physics section here. Okay, so let us see. Move to the very first question, and this is a statement based question. As you can see, given below are two statements. The first statement is a satellite is moving around Earth in the orbit very close to the Earth's surface. The time period of revolution of satellite depends upon the density of Earth. That is the first statement. Statement 2 is the period of revolution of the satellite is t equal to 2 pi square root of Re by G. That Re, okay. So they have given, so for satellite very close to the Earth's surface. This is the time period for a satellite very close to the Earth's surface, where Re is the radius of the Earth and G is the acceleration due to gravity. In the light of the above statements, choose the correct answer from the options given below. So let us see the validity of the first one. A satellite is moving around the Earth in the orbit very close to the Earth's surface. The time period of revolution of satellite depends upon the density of Earth. So first of all, this, if I first take this second statement, okay, this is about the time period and it is the correct statement. How you can prove that? You can just write the force acting mr omega square. Okay, if it is very close to Earth, okay, suppose that radius of Earth is equal to suppose this is Earth here and there is a satellite moving in it. Okay, satellite is here. That, so radius I am assuming to be small r. Small r is the radius. Okay, here is the satellite. This is a small r. Okay, that I am taking as the radius of the orbit. So you can write m into small r omega square, that is actually equal to the gravitational force acting on it. Okay, so m into small r omega square, it is equal to capital G into capital M into small m divided by small r square. From this, small m and small m cancelled out. Okay, because it is very close to the Earth, you can take r to be approximately equal to Re, which is the radius of Earth. Okay, so from this I can write Re into omega square, that is equal to G into capital M divided by Re square. This G into capital M divided by Re square, it is nothing but small g, that is acceleration due to gravity on the surface of Earth. So Re into omega square, that is equal to G. Or you can write this omega square is actually equal to G by Re. From this you can write omega is actually equal to square root of G by Re. Because omega is equal to 2 pi by T. From this I can easily write 2 pi by capital T is equal to square root of G by Re. And from this you can write time period is actually equal to 2 pi into square root of Re by G. So our statement 2 is actually correct. Okay, statement 2 is correct. Now what about the second statement? So time period, that you can write as 2 pi into square root of Re, and in place of G, small g, if I want to convert it into the form of density, so I can write G is actually equal to G into capital M divided by Re square. That capital M can be written as 4 pi by 3 into capital Re cube into rho. Okay, this is actually the mass. So the first term, this 4 pi by 3 into Re cube, that is the volume, into density, which will give me the mass. G divided by Re square. So from this I can write this small g is 4 pi by 3 rho g into Re. The time period was Re by small g. So if I do that Re by small g, you can get T is equal to 2 pi into square root of Re divided by this 4 pi by 3 divided by rho divided by G divided by Re. Okay, and you can get this time period is actually 2 pi divided by square root of 1 divided by 4 pi by 3 divided by rho divided by g. Okay, so that time period is nothing but inversely proportional to square root of the density. So it is actually depending on the density. So a satellite is moving around Earth in the orbit very close to the Earth's surface. The time period of revolution of satellite depends upon the density of Earth. This is actually a correct statement. So both the statements are correct. Both statement 1 and statement 2 are true. This is the correct option for this question given. Okay, so correct answer is 2. Let's move to the next one. Question number 27, okay, in that paper. Question number 2 of the physics section it is. Okay, a uniform bar of length 12 centimeter and mass 20 meter lies on a smooth horizontal table. 2 point masses small m and 2m are moving in opposite direction with a speed of v and in the same plane as the bar as shown in figure. These masses strike the bar simultaneously and got stuck to it. After collision, the entire system is rotating with angular frequency omega. The ratio of v and omega is. Okay. So in this question, you just need to make the angular momentum conserved. Okay, you just need to make the angular momentum conserved. So you can write just angular momentum Li, initial angular momentum, is equal to final angular momentum. So initial angular momentum, if you see here, velocity of this point mass m, it is in the upward direction. Okay, and here is the center of mass of this rod. This is the center of mass. If you draw the position vector from this center of the rod, which is the center of mass, this will be the position vector. Now if you see, velocity is in the upward direction. Velocity is in the upward direction. So this is r vector, this is p vector. So r cross p, that will be the direction of angular momentum. Okay, that will be the direction of angular momentum and it is out of the plane. Likewise here, if you draw the position vector of the second one, and this velocity is in the downward direction. Now if you take this r cross p, so r vector will be actually this. So r cross p, that will be again out of the plane. So they both are having the same direction. So angular momentum initially, if you just write the magnitude, it will be equal to twice of m into its velocity multiplied by this distance. Okay. So velocity they are taking to be as, okay, so a uniform length of angular momentum initially. Okay, if you see this angular momentum initially, that is actually equal to, okay, so 2.1 velocity, speed is v, okay, 1 is 2m, okay, so you can write 2m into v, and let me call this distance initially as r1, okay, plus m into v into r2. What is that r1? r1 is equal to 2 centimeter. What is that r2? r2 is equal to 4 centimeter. So this is the initial angular momentum. The final angular momentum when these two get stuck on that bar. Now what will happen? This bar will start rotating about an axis which is perpendicular to the plane of this bar and going through this center. Okay, so final angular momentum, if you write, that is actually equal to, okay, suppose it starts rotating, okay, and that rotation will have this sense, right, anti-clockwise. In the anti-clockwise sense, it will start rotating with an angular speed omega. So final angular momentum, that you can just write as twice of m. Okay, let me write moment of inertia of this 2m particle here at the bar. So its moment of inertia is 2m into r1 square. So 2m into r1 square into omega plus m into r2 square into omega plus the moment of inertia plus the angular momentum of this bar about this, okay, about this axis, and that is actually equal to ml square by 12 into omega. L is the length of that bar. So mass of that bar is actually 20 m. So I am directly writing here 20 into m into L square divided by 12 into omega. That is the final angular momentum. If you put both of them equal, if you put twice of m into v into r1 plus m into v into R2, and that is actually equal to twice of m into R1 square into omega plus m into R2 square into omega plus 20 by 12. Okay, that is 5 by 3. 5 by 3 into m into L square into omega. So this you can have. Now from this we can see m is being cancelled out in each of them, and you put the values of R1 and R2. Then what you are going to get? Twice into V into R1. R1 is 2 centimeters, so 2, plus this R2 which is 4 centimeter, so 4 here, and it is equal to 2 into R1 square which is 4 into omega plus R2 square, that is 16, so 16 into omega plus 5 by 3 into L square. Okay, so the length of it is given as 12. Okay, if you make a square of it, that is 144. So 144, okay, into omega. Let us see now. So 4V plus 4, okay, and okay, so 4V plus 4V, that is equal to 8 omega. This will give me 48. Okay, so 8 omega plus 16 omega plus 240 omega. If you add them, so 240 plus 8, that is 248 plus 6, which is 254, so 264 omega. That comes out to be 8V. Now we want to find out the ratio of V and omega. So this V by omega is actually equal to 264 divided by 8. And now how much it is? 33. That is the first option. So first option is the correct one for this question. Now the next one. A laser beam has an intensity of 4.0 into 10 raised to the power 14 watt per meter square. The amplitude of magnetic field associated with the beam is. You have to find that in Tesla. So you can write intensity is actually equal to B square divided by 2 mu naught. Or if I use that formula for intensity, you can just remember one formula and you can modify that. So 1 by 2 into C into epsilon naught into E square. So in place of E, there is a relation between E and B. E by B is actually equal to C. Okay. So you can write 1 by 2 into C into epsilon naught. In place of E, you can write that BC. So B square C square. That C square is, okay, so you can have 1 by 2 into C into epsilon naught into B square divided by mu naught epsilon naught. So B square into C divided by 2 mu naught. Okay, that will be the intensity. If you now use this formula 4.0 into 10 raised to the power 14. So you can write 4.0 into 10 raised to the power 14. That is equal to B square. Okay. Into C, which is 3 into 10 raised to the power 8. Divided by 2 and divided by mu naught. Okay. So divided by 2 divided by mu naught. So mu naught I am just writing as 4 pi into 10 raised to the power minus 7. If I calculate it, B square comes out to be 4.0 into 10 raised to the power 14 into 2 into 4 pi into 10 raised to the power minus 7 divided by 3, okay, divided by 10 raised to the power 8. Okay, now going to calculate it, you can just write B square is actually equal to 4 into 2 into 4 pi divided by 3 into 10 raised to the power 6, 10 raised to the power minus 7, so 10 raised to the power minus 1. So you can have just 4 into 2, that is 8, 8 by 3 into 0.4 into, okay, 4 into 3.14. So you can have 4 into 0.314. 32 divided by 3 into this 0.314. Okay, and if I, okay, so you can easily do that around 10.7. Okay, so B square is actually equal to 10.7 into 0.314. B square is 10.7 into 0.314. Okay, so that will be nearly 3, right? If I multiply this 0.314 by 10.7, you are going to get nearly 3 as the value. Square root of 3, that will be nearly, okay. So I can easily guess the answer without doing the actual calculation, okay. So you can write b square is just the square root of this 10.7 into 0.314, and it comes out to be 1.83. Okay, there is only one option which will give you the square root of, which will have a value equal to the square root of, nearly equal to the square root of 3. Okay, so the right answer is 3, third one. Let's see the next question. The smallest wavelength of Lyman series is 91 nanometer. The difference between the largest wavelengths of Pascal and Balmer series is nearly. Okay, that is the question. So for the Lyman series, okay, so Lyman is the first one. Okay, so Lyman series, I can write 1 by lambda L is equal to R, which is the Rydberg constant, into 1 by 1 square minus 1 by n square. That we can write for the Lyman series, this formula. This n is actually equal to 2 or 3 or 4, and up to infinity we can go. Now we are talking about the, okay, smallest wavelength. So when the smallest wavelength is possible, okay, a smallest wavelength is possible if n is maximum. Okay, if n is equal to infinity. Smallest wavelength means highest energy, and that is possible when electron is jumping from the highest possible orbit to the lowest one. Okay, so n equal to infinity, you can write 1 by lambda L is actually equal to R, or this lambda L is actually equal to, okay, lambda L max. Okay, they are writing the smallest one. Okay, so 1 by lambda L minimum I am taking. Okay, so lambda L minimum is going to have this value. Let me mention here, lambda L minimum is going to have this value, that is 1 by R, and it is equal to 91 millimeter. Okay, that is equal to 91 millimeter. If you take that, one is this equation I can have the difference between the largest wavelength of Pascal. Okay, so Lyman, Pascal and Balmer. So for Balmer, first let me write, for Balmer I can write 1 by lambda B, okay, is equal to Rydberg constant into 1 by 2 square minus 1 by n square. That n can be anything greater than 2, an integer greater than 2. So I want now the largest one. So for the largest wavelength n is actually equal to 3. So you can write this 1 by lambda B is equal to R into 1 by 2 square, which is 1 by 4 minus 1 by 9. Now you can write this R, 36 you can take as the LCM, 9 minus 4. Okay, that is equal to 1 by lambda B. Now this lambda B is actually equal to 36 by 5R. Okay, and this is the maximum wavelength. Okay, I can also write, okay, let me write it just as lambda B max. It is equal to 36 by 5R. Now you can calculate for the Pascal one. Okay, so for the Pascal you can write 1 by lambda P is actually equal to R into 1 divided by 3 square minus 1 by n you can take as 4 for the maximum wavelength of Pascal series. 1 by 3 square minus 1 by 4 square. Now you can write this 1 by lambda P is actually equal to R into 1 by 9 minus 1 by 16. So R into, you can take that 144 as the LCM, 16 minus 9, it is equal to 1 by lambda P. Now you can write this lambda P is actually equal to 144 divided by 7R. That is the maximum wavelength in Pascal. Now according to the question, so the difference between the largest wavelength of Pascal and Balmer series we want to find out. Okay, so I want to find out the difference of 36 5R, 144 by 7R. So this difference, let me mention as delta lambda, is actually equal to 36 by 5R minus 144 by 7R. So if you take this 35R as the LCM, okay, 252 then 720. Okay, so I just want the difference. So let me put okay, this more mod around it. Now you can write 720 minus 252. This comes out to be 8, okay, then 4, divided by 35 divided by R. But according to the question, this 1 by R is 91 millimeter. So you can put this value 488 divided by 35 into 91. So 7, 5, then okay, this is 13. So 48, you are going to get 488 into 2.6. 488 into 2.6. If you calculate it, 488 into 2.6, so this is nearly 500. 500 into 2, that is 1000 and 300. So this should be the answer. Okay, that third one must be the answer for it. 1217. Okay, without doing the actual calculation, you can guess the answer. Okay, 1217, that will be the answer of it. Now the next one. In an open organ pipe, nu3 and nu6 are third and sixth harmonic frequencies respectively. If nu6 minus nu3 are 2200 hertz, then length of the pipe is. Okay, so you can write actually for the nth harmonic, frequency is given by n into velocity. Okay, speed of sound in the open organ pipe, and obviously there is air. So NV divided by 2L. Okay, NV divided by 2L. We want to know that that length. Okay, we want to know that length. So from this expression, I can write nu6 is actually equal to 6V divided by 2L, and nu3, that is just equal to 3V divided by 2L. If you take the difference, you can have 6V by 2L minus 3V by 2L. Okay, you can write this. Now, you can write 6V by 2L minus 3V by 2L, that is actually equal to 3V by 2L, and it comes out to be, this difference is actually 2200 hertz. Okay, this difference is 2200 hertz. I can write this length is actually equal to 3V divided by 2 divided by this 2200. So 3 into V, that is 330 divided by this 2 divided by 2200. Okay, so 3 into, okay, 30 divided by 2 divided by 200, 0 and 0 cancelled out. Okay, so you have how much? Length we want to find out. Okay, so 3V by 2L. So length is actually equal to, they are asking in millimeter, fine. 3 into 3 divided by this 40, that will be the length. If they are, okay, and it comes out to be, because I am writing all the values in SI units, so I will get this value in meter. To convert it into millimeter, you can multiply by 10 raised to the power 3. Now, 10 raised to the power 3, which is 1000. Okay, 1000 divided by 40. Okay, how much it is going to give me? That is going to give me 25. So 9 into 25, and that is 225 millimeter is the answer for this question. First option is the correct one. Very easy question. Okay, 275, but this will be the answer. Okay, 225 will be the answer. Okay, now let's see this question number 31, and the question is, figure shows the circuit that contains 3 resistances 9 ohms each, 2 inductors of 4 millihenry each. The reading of an ammeter at the moment switch K is turned on is. Okay, where is that switch? Here is the switch. So as soon as you make that switch on, okay, as soon as you are going to make that switch on, the current through the inductors, okay, at that instant at t equal to 0 is 0. Current through the inductors are 0. Because the currents are 0, okay, through the inductors, the branches which are having inductors, current is 0. So current is 0 here. Let me call it I1. I2, if the current is, so this is also 0. Now the current is only going through this branch, okay, which is having 9 ohm of resistance. So I can write the total current, okay, the reading of the ammeter, the total current going through this battery, generated by this battery, this I, is actually equal to EMF of the battery divided by the resistance of 9 ohm. So 9 divided by 9, it comes out to be 1 ampere. 1 ampere. So 1 ampere, that will be the current. Now the next question, the wavelength of light while it is passing through the water of 540 nanometer, the refractive index of water is 4 by 3. The wavelength of the same light when it is passing through a transparent medium having refractive index of 3/2 is. So you know that wavelength in a medium, that can be written as wavelength in vacuum divided by the refractive index of that medium. Or you can just write wavelength is actually inversely proportional to mu. Okay, if I am taking mu as the refractive index. Using this expression, we can just write lambda 1 by lambda 2 is actually equal to mu 2 by mu 1. Lambda 1 by lambda 2 is actually equal to mu 2 by mu 1. Now you put all the values. What we want to find out, so we are given wavelength of light while it is going through the water and it is 540 millimeter. Let me take it as lambda 1. Okay, let me take it as lambda 1. So you can write lambda 2 is actually equal to mu 1 by mu 2 into lambda 1. What is that mu 1? Mu 1 is the refractive index of water and that comes out to be 4/3. So you can write it as 4/3. Refractive index of transparent medium in which we want to find out the wavelength of it. Okay, that is given by 3/2. Okay, so you can put here 3/2 into lambda 1. Lambda 1 is 540. So this is actually 8 divided by 9 into 540. This is 60. 60 into 8, that is 480 nanometer. Okay, so 480 nanometer. Third option is the correct one. Third option is the correct one. Now the next one, an electric power. Okay, an electric power line having total resistance of 2 ohm delivers 1 kilowatt of power at 250 watt. The percentage efficiency of transmission line is. So we can find out if the voltage is given, I can find out with what current it has been delivered. What will be the current through the transmission lines? Power delivered P, that is VI, and it is equal to 1 kilowatt according to the question. This is actually the power delivered. This is the output power. Voltage, okay, at this voltage it is being delivered at 250 volt. So I can write here 250 into current I, that is equal to 10 raised to the power 3. Now you can write this current I is equal to 10 raised to the power 3 divided by 250. 10 raised to the power 3 divided by 250, and this comes out to be 4 ampere, not 40 ampere. 1000 divided by 250. 100 divided by 25 is 4. 1000 divided by 250 is also 4. Now what is the power wastage? Okay, what is the power, what is the heat dissipation in the transmission line on those, okay, in those wires through which the power is being transferred. Okay, so that I can say this is the wasted power. Okay, or okay, so let me write this as delta P. That delta P, power loss, is equal to delta P, and it comes out to be I square into the resistance. I square into R. Okay, I square into R, that is the power loss in the transmission lines. Now I is 4 ampere, so 4 square into the resistance, which is 2 ohm. So 16 into 2, that is 32 watt. That is the power. Now what you can do here, so the percentage efficiency we want to write. Okay, so 4 square into 2, this is the power wasted, 32 watt. So how much is the efficiency? So what is the input power if I write? Input power is actually equal to this 32 plus 1000. Okay, 1032 watt. That is the input power. The output power is just equal to 1000. So efficiency is just equal to PO by Pin into 100. So 1000 divided by 1032 into 100. So you have 500 divided by 516 into 100. Okay, so this comes out to be nearly 250 divided by 258 into 100, or I can also write it as 125 divided by 129 into 100. Okay, so that answer will be very much close to 100. Okay, if you calculate this answer, you are going to get 96.9%. Okay, nearly approximately 96.9% as your answer you will get. Okay, so the first option is the correct one. Now This question number 34. 5 positive charges, each having charge Q, are placed at the vertices of a percentage as shown in the figure. The electric potential V and the electric field E at the center O of the pentagon due to these 5 positive charges are. So if I talk about just the center, okay, if I just talk about the center, electric field at the center due to any of the charge, okay. So let me draw this. Suppose this is the electric field. This is the electric field because of a second charge, because of the third one, and because of a fourth one, and because of the fifth one here. Now all those electric fields, okay, they are actually going to make same angles. That angle will be 72 degrees between them. 72 degrees is the angle between these electric fields. Because it is a regular pentagon, they all are equal charges. Okay, so electric fields are going to cancel each other out. So net electric field is 0. If you write the net potential, so net electric field is 0. If you write the net potential, that is just the 5 times of the potential by 1. Potential by 1 is Q divided by 4 pi epsilon naught R, because from each of the vertices, from each of the vertex, the distance of center is small r. Okay, so you can write the total potential at the center is 5 times of Q divided by 4 pi epsilon naught divided by small r. Okay, so the correct option is the first one. The first option is the correct one. Now the next question. 3 small identical bubbles. 3 small identical bubbles of water having same charge on each coalesce to form a bigger bubble than the ratio of the potentials on one initial bubble and that on the resultant bigger bubble is. So radius will actually change. So 3 small identical bubbles of water having same charge. So suppose each of the small bubble is going to have a charge small q and radius is small r. Now there is a bigger drop you are making by combining these 3 drops. Okay, so suppose this is the bigger drop. Now this bigger drop will have a charge 3 times of small q. How about the radius? So suppose radius is capital R. Now you can write volume of the 3 small bubbles is actually equal to volume of a single bigger one. Okay, so you can write 4 pi by 3 into capital R cube. This is equal to 3 into 4 pi by 3 into small r cube. This factor is cancelled out. So capital R cube is actually equal to 3 times of small r cube. You can write capital R is equal to 3 raised to the power 1 by 3 into small r. 3 raised to the power 1 by 3 into small r. Now what you can do, you can find out the potential of the smaller one. Let me call as Vs. Okay, that Vs is actually equal to Q divided by 4 pi epsilon naught divided by small r for the bigger one, Vb. Okay, that is capital Q divided by 4 pi epsilon naught divided by capital R. Okay, if you take the ratio Vs to Vb, so what they are asking, then the ratio of the potential on one initial bubble and that of the resultant bigger bubble. Okay, so if you divide, it comes out to be small q divided by capital Q into capital R divided by small r. What is our small q? Small q by capital Q. So small q by capital Q, from this relation you can see small q by capital Q is equal to 1 by 3. Okay, so that is equal to 1 by 3. Okay, so this is just 3 raised to the power 1 by 3. You are going to get 1 divided by 3 raised to the power 2 by 3. So 1, 2, 3 raised to the power 2 by 3. This is the answer. Option number 4. That is the correct one. Now the next question, 36. In parallax method, for the determination of focal length of a concave mirror, the object should always be placed. Okay. The very first option, between focus and the center of curvature of the mirror only, between the pole and the focus of the concave mirror only, beyond the center of curvature of the mirror only, okay, at any point beyond the focus of the mirror. So the correct option for this is between the focus f and the center of curvature. Okay, this can be true. Beyond the center of curvature of the mirror, okay, this can also be true. There are 2 options correct here. Okay, 1 and 3. So if this is the concave mirror and you put that object, that pin before it, you can put it between the center of curvature and the focus. You can also put it beyond the center of curvature. Okay, anywhere you can put it, so that an inverted image of this pin is being formed. Okay, if that is inverted, only then, okay, you know that when you use this method, you see through the, there must be an inverted image formed, and that inverted image can only be formed if this object is beyond C or between the center of curvature and the focus. So these are the two options correct here. Not here between focus and the pole, because in that case image will be an upright image. Okay, you will get an upright image. Now question number 37. Given below are two statements. Okay, so there are two statements given. Statement 1 is an object moves from position R1 to position R2 under a conservative force field F. The work done by the force is W equal to minus of R1 to R2 F dot dr. So this is incorrect. It must be a positive one, so incorrect. False statement it is. Second statement, statement 2. Any object moving from one location to another location can follow infinite number of paths. Therefore, the amount of work done by the object changes with the path it follows for a conservative force. This is also false. Though it can follow a number of, infinitely many number of paths, but the work done is not path dependent. Okay, it is same for all of them. So both the statements are false. This is the right option. Now next question. Using a simple pendulum experiment, G is determined by measuring its time period T. Which of the following plots represent the correct relation between the pendulum length L and time period T? Very simple question. You can just write the formula for the time period. 2 pi square root of L by G. You make a square of both sides. T square is 4 pi square into L by G. Now you can write 1 by T square. This is actually equal to G by 4 pi square into 1 by L. Okay, so what I am trying to do, we are trying to plot a graph between 1 by T square and L. So I have changed, my equation to this. Now 1 by T square into L. You can write 1 by T square into L. That is equal to G by 4 pi square. If you plot 1 by T square on the y-axis and length on the x-axis, they are taking capital L. So let's take capital L. In place of 1 by T square, you can write y. In place of this small l, you can write x. And that is actually a constant. So this equation is actually representing a rectangular hyperbola. So the correct answer here is, as the length is increasing, so this will be the answer. As the x is increasing, value of y is decreasing. So third option, rectangular hyperbola will have this shape. This is the answer. Third option is the correct one. Now the next question, question number 39. When a part of a straight capillary tube is placed vertically in a liquid, the liquid raises up to a certain height h. If the inner radius of the capillary tube, density of the liquid and surface tension of the liquid decreases by 1% each, then the height of the liquid in the tube will change by. So you can write this height, you can write that height is actually equal to 2t cos theta divided by r rho g. So you can write 2t cos of theta divided by r rho g. That theta is the contact angle. So you can write dh by h is actually equal to dt by t minus, dr by r, minus d rho by rho. If you write in percent, that change in percent, I can also write that dh by h percent is actually equal to dt by t percent, minus dr by r percent minus d rho by rho percent. Now you know that this dt by t percent, surface tension is, so if the inner radius of the capillary tube, density of the liquid and surface tension of the liquid decreases by 1% each, then the height of liquid, density of the liquid, surface tension of the liquid, they all are decreasing. Also the inner radius. So if you take dt by t in percent, that is actually minus 1. Also dr by r, that is minus 1. Also this d rho by rho, that is minus 1. If you put here, you have minus 1 plus 1 plus 1, that is plus 1%. So that is plus 1%. So it is being increased by plus 1%. So plus 1 is the right answer. Option 2 is the correct one. Okay, correct option for this. Question number 40. The correct table for the given input data of the following logic gate is, okay, that you need to find out. So the first gate is an AND gate. It is going to give an output A dot B. The second gate is an OR gate. It is going to give an output C plus D. This NOT gate is going to give an output A, B bar. Okay. Here, so you can see from this from the second AND gate, okay, here at this AND gate, output is actually equal to product of AB bar and C plus D. If you have a NOT, okay, again here, so the final output, okay, is actually Y bar. So if you make a bar of it, AB bar dot, okay, into C plus D and bar of it, this is going to give me AB bar bar, okay, dot C plus D bar. Okay, just 1 second. AB bar bar plus C plus D bar. Okay, that you will get. What I am using here, I am using this fact that A dot B bar is actually equal to A bar plus B bar. Okay, so these are the two terms. I am assuming this AB bar as AB as A and C plus D as B. So you can write this. Now AB bar bar, that is AB plus C plus D bar, it is going to give me C bar dot D bar. Okay, again I am using this fact that A plus B bar is actually equal to A bar dot B bar. Okay, now check the truth table. If you make a truth table with A, B, C and D, so you can check one by one. Okay, let us have the first one. If you take 1 and 1, AB is 1 and 1. So AB, that is 1. C is 0, D and D is 1. So this is going to give me C bar, which is 1, D bar, which is 0. So this will be 0, but this is 1. So it must be 1. Okay, when A and B both are 1, this product must be 1, which is not. Okay, so first one is not true. If I check the second one, in this first entry is matching. 1, 1, okay, then it is 1. If you take 0, 0, this is 0. But if you take CD as 1, 1, so this is also 0, so again 0 you are getting. This entry is also correct. For the second option, A, B, okay, A is 1, B is 0, so this product is 0. Then C bar is 0, D bar, that is 1, again this product is 0, so this is 0. If you take all of them 4, again AB will give you 1, but this last one, it is going to give you 0. So the correct option is the second one here. Okay, second option will be the correct one. Now let's take the next one. Consider two boxes containing ideal gases A and B such that their temperatures, pressure and number densities are same. The molecular size of A is half of that of B and mass of molecules is 4 times that of B. Okay, if the collision frequency in gas B is 32 into 10 raised to the power 18 per second, then collision frequency in gas A is. So first of all, you can write the frequency F is equal to average speed divided by mean free path. If you write V bar, that comes out to be just square root of 8 kT by pi m. And if you write this lambda, that is 1 divided by square root 2, okay, n pi d square. Okay, from this V bar by lambda, if everything is constant, K is already a constant, that is Boltzmann constant, 8 is a constant, pi is a constant. If temperature, okay, so consider two boxes containing ideal gases A and B such that their temperatures, pressure and number densities are same. Okay, the molecular size A is half that of B and mass of the molecule A is 4 times that of B. So if you write frequency here, okay, that frequency will actually be equal to square root of 8 kT by pi m, and if this is 1 by lambda, so you are going to get here square root of 2n pi d square, and from this we can write frequency. Okay, frequency is just proportional to d square by square root of m. Proportional to d square by square root of m. So you can write frequency of A Okay, so what they are asking, if the collision frequency in gas B is given, so you can write frequency in A divided by frequency in B is equal to dA square divided by dB square into square root of MB divided by square root of MA. Now the molecular size of A is half that of B. Okay, so dA by dB, it is 1 by 2. So 1 by 2 is square, that is 1 by 4. Okay, what else given? Mass of molecule A is 4 times that of B. Okay, mass of molecule A is 4 times of B. So you will get 1 by square root of 4, which is 2. So 1 by 8. Fa by Fb is 1 by 8. Now you can get Fb is actually equal to 8 times of Fa. Okay, I want Fa. So Fa is equal to Fb by 8. This is given as 32 into 10 raised to the power 8. You divide it by 8, you are going to get 4 into 10 raised to the power 8 as your answer. Now the next one. If epsilon E and T represents the free space permittivity, electric field and time respectively, then the unit of epsilon E by T is. They have defined a physical quantity epsilon E by T. So this physical quantity, let me take as A. A is equal to epsilon E divided by T. Now epsilon, okay, that is the permittivity. Permittivity can have dimensions if you use the force formula between two charges. 1 by 4 pi epsilon q1 q2 divided by r square. Suppose in a medium which is having permittivity epsilon, there are two charges capped q1 q2 at a distance r from each other. Okay, and now you can write this epsilon is going to have dimensional formula same as the dimensional formula for charge square divided by meter square, okay, divided by Newton. Okay, that will be the dimensional formula for epsilon. E is the electric field. So electric field that will have the same dimensions as Newton per coulomb. Okay, I'm just writing suppose in unit. Okay, what they are asking, they are just asking the units. So not dimensional formula, they are interested in the units. So I have written units of epsilon in terms of charge, coulomb, okay, then here meter and Newton. What is this T? T is the time. So now I can replace C square divided by M square into N into, in place of electric field you write N by C. In place of time you can write second C and okay, one power is cancelled out. What you are left with? Newton into coulomb divided by meter square divided by Newton divided by second. Newton and Newton cancelled out. Now coulomb per second, that is ampere. So ampere per meter square is the units, okay, is the unit of this given physical quantity. Next one, question number 43. Given below are two statements. Statement 1. For a mechanical system of many particles, total kinetic energy is the sum of kinetic energies of all the particles. This is true. Okay, this statement is true. Statement 2. The total kinetic energy can be the sum of the kinetic energy of the center of mass with respect to the origin and the kinetic energy of all the particles with respect to the center of mass as the reference. This statement is also true. How we can prove that? You can write, suppose there is ith particle given which is having mass mi. Now its kinetic energy of this can actually be written as 1 by 2 into small mi into ri dot square. Suppose ri dot, that is the velocity of the ith one. Okay, this is actually the derivative when I'm writing. Now total kinetic energy T, that is summation over Ti, and it will be summation over 1 by 2 into mi into ri dot square. Now what you can write the velocity, okay, or let me write just 1 by 2 m for simplicity m vi square. This is the velocity of ith particle. Now velocity of the ith particle with respect to the center of mass, let me call it vic. This can be written as velocity of the ith particle minus velocity of the center of mass. Okay, and obviously I should write in the vector form. Now if you write the kinetic energy of all the particles, kinetic energy of all the particles with respect to the center of mass as a frame of reference, with respect to center of mass as the reference, that means it is the origin. Okay, so I have to use this expression. So I can write 1 by 2 into mi into vic dot vic. This is the kinetic energy by taking center of mass as the reference. So you can write 1 by 2 into mi. You take vic dot vic. So you are going to get, I'm writing here vi square plus vcm square, okay, minus 2vi dot vcm. If you take a sum over it, what you are going to get, this is for the ith particle and this is with respect to the center of mass. So you can get 1 by 2 into mi vi square, okay, take this sum, plus 1 by 2 mi vcm square minus this term 1 by 2 of mi into 2 into vi dot vcm. If you now take the sum over all the terms, okay, you can get the total kinetic energy. Okay, I'm not going to fully do it. You will find out this term is actually 0. This term is 0. Now the total kinetic energy is just the sum of kinetic energy of all the particles with respect to center of mass plus the kinetic energy of the center of mass. Okay, that you are going to get. Okay, that you are going to get actually. VIC here is. So this is kinetic energy of all the particles with respect to center of mass itself. Okay, so the total kinetic energy can be written as the sum of kinetic energy of the center of mass with respect to origin and the kinetic energy of the particles with respect to the origin. So both terms are there. So both the statements are actually true. So the correct option here is the first one. Now 44. Which of the following are true of single slit refractions? So they are talking about the width. That width can be written as lambda into capital D by small d. You can write width beta as lambda into capital D by small d. Let's check now. So the first statement, width of central maxima increases with increasing in wavelength, keeping slit width constant. So width of central maxima increases with increase in wavelength, keeping slit width constant. So small d is the slit width. If you keep it constant and increase the wavelength, beta is going to increase. That is true. B, width of central maxima increases with decrease in wavelength, keeping slit width constant. So if you keep this d constant and you decrease the wavelength, then width is going to decrease. So this is incorrect. Width of central maxima increases with decrease in slit width at constant wavelength. So width of central maxima increases with increase in slit width. If you increase the slit width, okay, beta is going to decrease. So this is also incorrect. D, width of central maxima increases with increase in slit width at constant wavelength. Width of central maxima increases with increase in slit width. So so this is also incorrect. Brightness of central maxima increases for decrease in wavelength at constant wavelength. This is not depending on the wavelength. Okay. So width of central maxima increases with decrease in slit width. This is actually correct because if D is decreasing, beta will increase. So there are two statements correct, A and C, but none of the option is matching here. Light is incident on a metallic plate having work function of 110 into 10 raised to the power minus 20 joule. If the produced photoelectrons have zero kinetic energy, then angular frequency of the incident light is. So light is incident on a metallic plate having work function. So work function that is equal to 110 into 10 raised to the power minus 20. If the produced photoelectrons have zero kinetic energy, then the angular frequency of the light incident is. Okay. I'm assuming that this angular frequency, what is that angular frequency? So first let me calculate the frequency. H nu is actually equal to 110 into 10 raised to the power minus 20. Nu is actually equal to 110 into 10 raised to the power minus 20 divided by 6.63 into 10 raised to the power minus 34. So you can get 110 divided by 6.63 into 10 raised to the power 14. You multiply it by 2 pi and you can get that angular frequency omega. So 2 pi into 110 divided by 6.63 into 10 raised to the power 14. 6.63, okay, so 110 divided by 6, that is approximately 20. 20 into 2, that is 40 into pi, that is 120. Okay, maximum kinetic energy that we write as h nu minus the work function. because it is 0, so h nu is equal to w. That I am doing correctly. Okay, so just do the calculation carefully, you will get your answer, and it is 1.04 into 10 raised to the power 13. Now 46, a conducting circular loop is rotated about its diameter at a constant angular speed of 100 radian per second in a magnetic field of 0.5 Tesla perpendicular to the axis of rotation. When the loop is rotated by 30 degree from the horizontal position, the induced EMF is 15.4 millivolt. The radius of the loop is, okay, so you can write associated magnetic flux, that is actually equal to BA cos of omega t. Okay, if you take the EMF d phi by dt, that is minus d phi by dt, and on calculation you are going to get BA omega sine omega t. So when the loop is rotated by 30 degree, that means this omega t is 0 degree. Okay, so you can write EMF is actually equal to magnetic field B, and the value of magnetic field is 15.4. 15.4 into 10 raised to the power minus 3. Area we can write just as pi small r square. Omega, okay, that is the angular speed, it is given by 100. Sine omega t, that is sine 30 degree. So 1 by 2. Okay, and value of this EMF, okay, that is given by, okay, value of EMF is given by 15.4. Value of magnetic field is 0.5 Tesla. So let me just 15.4 into 10 raised to the power minus 3. Okay, this comes out to be 0.5 into that area pi r square. Okay, now 15.4 into 10 raised to the power minus 3 equal to 0.5 into 22 by 7 into small r square into 10 raised to the power 2 into 1 by 2. Okay, so 0.5 divided by 1 by 2, so that is 1 by 4. So you will get 4 into 15 by 4 into 10 raised to the power minus 3 is actually equal to 22 by 7 into r square. If you multiply 22 by 0.7, so this will give me 0.7. Now you can write this small r square is equal to 4 into 0.7 into 7 into 10 raised to the power minus 3. Okay, so you can get 4 into 7 into 7 into 10 raised to the power minus 4. You can get r is actually 2 into 7 into 10 raised to the power minus 2. Okay, so this is just 14 centimeter. Okay, but they are asking in millimeter. Let me calculate once more. Let me check this. 7 into 7 into 10 raised to the power minus 4. So 2 into 7 into 10 raised to the power minus 2. In millimeter, that will be 140 millimeter. So I think 140, that must be the answer. Okay, 14 is the answer. Just 1 second, let me check somewhere. 15.4, this is 0.5 Tesla pi r square. Okay, r square into 10 raised to the power 2 into sine 30 degree. So 4 into 22 into 0.7. Okay, so 4 into 0.7 into 10 raised to the power minus 3 into 7. That I am writing correctly. 7 into 7, then 2 into 7 into 10 raised to the power minus 2. Okay, and that is actually meter. Okay, so somewhere, okay, there is a mistake in the decimal point. So yeah, this one r square into 10 raised to the power 2. If I take this 10 raised to the power 2 towards left, you will have 10 raised to the power minus 2. So this is 10 raised to the power minus 6. On taking a square root, you will get 10 raised to the power minus 3. So 14 millimeter. Okay, 14 millimeter will be the right option. Now there is a capacitor P with capacitance 10 into 10 raised to the power minus 6 farad is fully charged with a potential difference of 6.0 volt and disconnected from the battery. The charged capacitor P is connected across another capacitor Q with capacitance 20 into 10 raised to the power minus 6 farad. The charge on the capacitor Q when equilibrium is established will be alpha into 10 raised to the power minus 5. What is the value of alpha? So charge on P, capacitor P with capacitance is fully charged with a potential of 6.0. So charge on P is actually equal to 6.0 into 10 into 10 raised to the power minus 6. That is 60 microcoulomb. Charge on Q. Okay, so let me write Q1. Charge on Q is initially 0. So net charge when they two are connected, net charge is now equal to 60 microcoulomb net capacitance, it is equal to, they are in parallel, 10 microfarad and 20 microfarad, so this is 30 microfarad. Common potential Vc, this is equal to net charge divided by net capacitance. Net charge is 60 microcoulomb and this is 30 microfarad. It comes out to be 2 volt. Okay, it comes out to be 2 volt. What I want to find out, so the charge on capacitor Q, on the second capacitor, okay, on the second capacitor, charge Q2 dash, okay, after connection I am writing. This is equal to its capacitance of Q, which is 20 microfarad into common potential, which is 2 volts, so 40 microcoulomb. 40 microcoulomb, that will be the answer. So 40 into 10 raised to the power minus 6. You can write it as 40 into 10 raised to the power minus 6, which is 4 into 10 raised to the power minus 5. And you can write it as alpha into 10 raised to the power minus 5 coulomb. You can have alpha is actually equal to, one second, alpha into 10 raised to the power minus 5. Okay, I am getting 4 into 10 raised to the power minus 5. 60 microcoulomb, 10 microcoulomb, then 20 microcoulomb, sorry, 20 microfarad, 30 microfarad. Net charge is 10 microfarad and 6. Okay, so this is 60 microcoulomb. Now 60 microcoulomb divided by 30 microcoulomb, that is 2. So 2 into 20. So 40 microcoulomb, that will be the charge, which can be written as 4 into 10 raised to the power minus 5. So the value of alpha is 4, not 40. Okay, that will be 4. An insulated cylinder of volume 60 centimeter cube is filled with a gas at 27 degrees Celsius and 2 atmospheric pressure. Then the gas is compressed, making the final volume as 20 centimeter cube. While allowing the temperature to rise 77 degrees Celsius, the final pressure is atmospheric pressure. Okay, so you can write P1 V1 equal to T1, P1 V1 by T1 equal to P2 V2 by T2. Now you can write P1. Okay, what is that P1? P1 is 2 atmospheric pressure. What is that V1? V1 is equal to 60 centimeter cube. You can write T1, that is equal to 273 plus 27, which is 300 Kelvin. Okay, so you can now write here 2 into 60 divided by 30, that is equal to P2 into V2. Okay, let me put the value directly. This is 20 here. Temperature, that is 273 plus 77. T2 is 273 plus 77 and it comes out to be 350 Kelvin. You put here 350. 0 and 0 cancelled out. Okay, 2 and 2. This 0 and 0, 3, 2. Okay, this P2 is actually equal to 70. One second. P1. Okay, let me take this P1. P1 is actually, let me write here, P1 is 2 atmospheric pressure. So 2 into 60 divided by temperature, which is 300, equal to P2 into V2. V2 is 20 divided by 350. Okay, so if this 0 0 cancel out, this is this 60. Okay, that will give me 5. So 2 by 5 equal to P2 into 2 divided by 35. This 2 and 2. So P2 is actually equal to 7 atmospheric pressure. And that will be the answer for this question. 49. A cylindrical conductor of length 2 meter and area of cross section 0.2 millimeter square carries an electric current of 1.6 ampere. When its ends are connected to a 2 volt battery, mobility of the electrons in the conductor is alpha into 10 raised to the power minus 3 meter square per volt per second. The value alpha is, how you can do that? So you can just write mobility V is actually equal to VD by E. What is that VD? VD is, I can write INE AVD. Okay, and this VD is actually equal to I divided by N divided by E divided by A. Okay, so I divided by NE, what you are given? Okay, so you are given 2 volt of battery. Okay, that is being connected. Electric current is there. Okay, so when it is, so there is a cylindrical conductor, suppose. The cylindrical conductor is having a length of 2 meter. There is a battery connected and this battery is of 2 volt, right? So first of all, you need to calculate the electric field, that is voltage applied 2 volt divided by the length of it, which is 2 meter, so 1 Newton per coulomb. Okay, that will be the electric field. Vd, that is just equal to I divided by NEA. Current is given to us. Current is 1.6. Number density, okay, if I see that density, electron concentration, this is 5 into 10 raised to the power 28. Charge on the electron, which is 1.6 into 10 raised to the power minus 19. Cross-sectional area, which is 0.2 into 10 raised to the power minus 6. Okay, and if you calculate that, this Vd is actually equal to 1.6 divided by, okay, 5 into 1.6, that is 8. 8 into 0.2, that is 1.6. So 1.6 into 10 raised to the power 9 minus 6, that is 10 raised to the power 3. This is cancelled out. So it comes out to be 1 into 10 raised to the power minus 3. Okay, that is the value of Vd. Value of E is also 1. So mu is actually 1 into 10 raised to the power minus 3. So value of alpha must be 1. Now the next question. Two masses m and 2m are connected by a light string going over a pulley of radius of mass 30 m with radius r equal to 1 meter. The pulley is mounted in a vertical plane and it is free to rotate about its axis. The 2m mass is released from rest and its speed when it has descended through a height of 3.6 meter is. So now what will happen? Suppose this is the pulley. This is the pulley here. There are two masses, one of 2m mass, the second one of m mass. Okay. As it is going down, it is losing the potential energy. Okay, it is losing the potential energy. That loss in potential energy is actually equal to gain in potential energy of this lighter one. Also the gain in kinetic energy of these two and the kinetic energy of this disk. So I can write loss in potential energy. So two masses m and 2m are connected by a light string going over a pulley, that is disk, of mass 30 m with radius r equal to 0.1 meter. The pulley is mounted in a vertical plane and it is free to rotate about its axis. The 2m mass is released from rest and its speed when it has descended through a height 3.6 meter is. Whatever the speed this is having, this is also the speed of the lighter one. Okay, so I can write loss in potential energy of the 2m mass. Let me write it as 2m into g into h. Suppose it has been descended by h. So this lighter one has also ascended by the same height. Okay, so 2mgh is actually equal to m into g into h plus 1 by 2 into 2m into v square plus 1 by 2 into m into v square. This is the kinetic energy of the 2m mass. This is the kinetic energy of m mass. And now I will write the kinetic energy of this disk, which is 1 by 2 into I omega square. Okay, rotational kinetic energy. So 1 by 2 into I omega square. Now you can write mgh is actually equal to 1 by 2. Okay, this is mv square. This is 3 by 2 mv square. Plus 1 by 2. Now this disk is having a mass of 30 m. And for disk, moment of inertia is 1 by 2 into its mass, which is 30 m into square of the radius into omega square. Now there is a relation between that speed v. Okay, so v is the speed with which this 2m mass is going down and this is going up. So any point here, this point of contact is going to have the same velocity, right? Same speeds they are going to have. So you can write v is actually equal to radius into omega. V is actually equal to radius into omega. So r omega is actually v. So v square. So you can write here mgh is actually equal to 3 by 2 mv square. Okay. This is 1 by 2. This will give me 15 by 2 mv square. Now 15 by 2 plus 3 by 2, that is 18 by 2. Okay, so you can have now 18 by 2 mv square. is equal to mgh. M and m cancelled out. So you can write this v square is actually equal to gh by 9. What is that? G is 10. What is that h? It is 3.6 divided by 9. Okay, so 0.4 into 10. V square is actually equal to 4. And you can write this V is 2 meter per second. Okay, so this is the speed of descending or ascending for these two blocks. So 2 will be the answer. So we have done with all the solutions, okay, with the solutions of all questions. So this is all for this session. Thank you everyone.